Assalamualaikum. My name is Muhammad Ruzaimi bin Makjuna from class DEP1B. My metric number 04 DEP21F1046.
My name is Muhammad Akmal Baihaki bin Hanafi. I'm from DEP1B. My metric number is 04 DEP21F1041.
My name is Hafiz Hamzani bin Muhammad Hussein. I'm from DEP1B. My matric number is 04 DEP21F1013.
Vector and scalar. Question 2. Two forces F1 and F2 are represented by vectors with initial points that are at the origin. The first force has a magnitude of 20 lb and passes through the point P bracket 110 close bracket. The second force has a magnitude of 40 lb and passes through the point Q bracket 0 1 1 close bracket. Let F be the resultant force of force F1 and F2. And now we will explain step by step question A and question B. Question A. Find the magnitude of F. The first step, the terminal point of the vector is point P, 1, 1, 0. Therefore, the direction of the vector F1 force is V1 equal bracket 1 minus 0 close bracket I plus bracket 1 minus 0 close bracket J plus bracket 0 minus 0 close bracket K. The answer equal 1I plus 1J plus 0K. The last answer equal I plus J. The second step, the unit vector F1 in the direction of force will be V1 divided by magnitude of V1 equal I plus J divided by square root 1 square plus 1 square plus 0 square. The answer 1 divided by square root 2 bracket 1 plus J. Step 3. The magnitude of the force is 40 lb. So the vector F1 will be F1 equal 40 times 1 divided by square root 2 bracket I plus J close bracket. The answer is equal 20 square root 2 bracket 1 plus J close bracket.
Step 4. The terminal point of each vector F2 is point Q bracket 0 1 1 close bracket. Therefore, the direction and unit vector of the vector F2 force is V2 equals bracket 0 minus 0 close bracket I plus bracket 1 minus 0 close bracket J plus bracket 1 minus 0 close bracket K equals 0 I plus 1 J plus 1 K. The answer is J plus K. V2 divided by magnitude of V2 equals J plus K divided by square root 0 square plus 1 square plus 1 square. The answer is 1 divided by square root 2 bracket J plus K close bracket. The next step is the magnitude of the force is 16 lb. So the vector F2 will be F2 equals 16 times 1 divided by square root 2 bracket J plus K close bracket equals 13 square root 2 bracket J plus K close bracket. The next step, addition of vector F1 and F2 to get vector F. F equals F1 plus F2 equals bracket 20 square root 2 bracket I plus J close bracket plus bracket 13 square root 2 bracket J plus K close bracket equals 20 square root 2 I plus 20 square root 2 J plus 30 square root 2 J plus 13 square root 2k. The answer is 20 square root 2i plus 50 square root 2j plus 30 square root 2k. The last step for question A is the magnitude force vector F will be magnitude of F equals square root bracket 20 square root 2 close bracket square plus bracket 50 square root 2 close bracket square plus bracket 30 square root 2 close bracket square equals square root 800 plus 5,000 plus 1,800 equals square root 7,600. The last answer is 87.178. If you want to change it one decimal place, the equals is 87.2 lb.
Okay, we go to question B. Find the direction angles of F. Okay, for the calculation, from calculation vector F, we calculate 20 square root 2i plus 50 square root 2j plus 30 square root 2k, or we can write in metric method 28.284, 70.711, and 42.426. This question does not mention what is angle we should calculate. So for this three-dimensional vector, we should calculate the triangle, which is vector F between x-axis, angle between y-axis, and angle between z-axis. We can calculate angle by using formula of r cos. So r cos, the dimension x or y or z, divide by the magnitude of the vector. So for angle formed by F and x-axis, alpha, we can write in alpha equal to cos -1 mean r cos. The unit of x, which is 20 square root 2 divided by the magnitude square root of 7,600. So we can get r cross 0.3244. We can get the angle of x axis 71.07. Okay, for the angle formed by vector f and y axis, the angle r cross y, which is 50 square root 2 divided by square root of 7,600, we get the r cos of 0.8111. We get the angle 35.80 degree. And the last, the angle formed by f and z axis. The angle r cross of z, which is 30 square root 2 divided by square root of 7,600, we get the r cos of 0.4867. The angle we get is 60.88 degree. So to compare the equation that we made with the calculation in online calculator or in modern method, the f vector we get from the calculation is 20 square root 2i plus 50 square root 2j plus 30 square root 2k. We put on ncalculators.com. This is to calculate the magnitude. Okay, 3D. 20 square root 2, we directly can write 28.28. For 50 square root 2, 70.711 J. 30 square root 2, 42.42 K. Okay, we press the calculate button and we get the magnitude of 3D vector 87.178. So this answer is same result as we calculate by our calculation. Okay, to compare the degree that we calculate before, we use a modern method of website geogebra.org. We can put the value of f value that we calculate before, 20 square root of 2i, which is the value is 28.28. This website just can input for 2 decimal places. So we input 28.28 for I, for J 70.71, and for K 42.43. And the resultant from this website shown, the result is same as we manually calculate before this. If someone asks me why you use 20 square root of 2, why you don't use directly 28.28? For engineering, we can make the value, rounding the value in early calculation. If we make rounding in early calculation, we will get the result. The final result is really different. If we make the building, maybe the final value is not accurate, not the real value, because the rounding method that we use, maybe the very high building will collapse because of the rounding method.